Hello everyone. Today we will be exploring the concept of multiplexer in digital logic circuits. As we know, a mux function as a data selector, meaning that by providing specific inputs, we obtain the corresponding output. So today we will work through two problems involving multiplexers. First, we will tackle a 4 to 1 mux and then we'll move on to 8 into 1 mux. Okay, so let's begin with a 4 to 1 mux. So here is your question. Choose suitable data line values and model an 4 to 1 multiplexer for function f of abc equal to summation m of 1, 3, 5, 6. Okay. So in this problem, we are given a Boolean function represented by sum of minterms 1, 3, 5 and 6. So now our task is to implement the mux accordingly. To do this, we start by creating a mux implementation table. Okay. So for a 4 to 1 mux, we have 4 data inputs. So that is nothing but D0, D1, D2 and D3 and one output which we will call Y. Right. So first we'll implement the mux implementation table. Okay. So in this mux implementation table, so first we have to write our 4 data inputs. So D0, D1, D2 and D3. Okay. Then we list all the 8 possible combinations of your selection line which is determined by 3 variables. Okay. So we have 3 variables A, B, C. So we will get 8 combinations. So 0, 1, 2, 3 and here 4, 5, 6, 7. Next we have to take the variable A here. So A bar and here A. And this B and C are your data selection lines. Okay. So here we are taking the A values. So now we will implement this table. So here we have to know for each combination whether the corresponding minterms is included in the function or not. Okay. If it is, we set the output to 1. If not, we set it to 0. Okay. So for that, first we have to circle the corresponding minterms. So 1 and then we have 3 and then we have 5 and then we have 6. Okay. In our first combination, both 0 and 1 are not included in our function. So that means we have to set it into 0. And in a second combination, 1 is included in our function and 5 is also included in our function. So we'll set it to 1. Next, in this one, 2 is not included in our function and 6 is included in our function. So that means we have to take the corresponding A value here. Next one, 3 is included in our function, 7 is not included in a function. So we have to take the corresponding A value here. So it's nothing but A bar. So this is our mux implementation table. With this mux implementation table, we can draw the logic diagram or block diagram for 4 to 1 mux and we have to connect the selection lines appropriately. Okay. So now we'll see the block diagram for this. So first, this is 4 is to 1 mux. We have to write like this. And we have 4 data lines. So that is nothing but D0, D1, D2 and D3. So now coming to D0. So D0, the corresponding value is 0. So 0 is nothing but ground. So we have to ground it. Okay. So next D1, it corresponds to 1. So that is nothing but power supply 5 volts. Okay. So now coming to a D2, that is nothing but A. So here we have to connect to A. And at last we have D3 value, that is A bar. So that is nothing but the complement of your A. Okay. So now we have to give the selection lines S1 and S0. So that is nothing but our B and C. Okay, so we'll get only one output, that is nothing but y. So y equal to our function. Clear? So this is your 4:1 marks. Okay, so now let's move on to your 8:1 multiplexer. Choose suitable data line values and model an 8:1 multiplexer for function f of a, b, c, d equal to summation m of 0, 1, 3, 4, 8, 9, 15. So in this problem, we have 8 data inputs. So D0, D1, D2, D3, D4, D5, D6 and D7. And we have 3 selection lines allowing to choose one of the 8 inputs to pass to your output. So we'll begin by examining the given Boolean function, which is represented by the sum of the minterms. So here the sum of the minterms are 0, 1, 3, 4, 8, 9 and 15. So our goal is to implement the 8 to 1 marks so that it reflects this function. So first we'll create this mux implementation table. So with 8 data inputs, we list all 8 possible combinations and 16 combinations of 3 selection lines. So now we'll circle all the min terms here. Okay. Then we have written A bar and A here, and 3 selection lines includes B, C and D. Okay. So here both the inputs are into a function, so we have written as 1, and here also 1 is included and 9 is included, so we have written as 1, and here the both the values are not included in a function, so it is set to 0, and here 3 is included, so the corresponding a value is a bar, and here 4 is included, the corresponding a value is a bar. So next here it's not included, so 0, and here also it's not included, 0, and here comes 15 is included in our function, so the corresponding a value is 8, right? So this is our marks implementation table. So with this marks implementation table, we are going to draw the logic diagram for 8:1 marks. Okay. So this is our 8:1 marks. So we have given the selection lines S2, S1, S0 as B, C, D. Okay. So and we have given the data inputs D0, D1, D2, D3, D4, D5, D6, D7 and it's 8:1 marks and one output here. So now D naught is nothing but we have given as 1 and D1 is also 1, right? So for that 1 is given to directly given to D naught and D1. And here the complement of 1 is nothing but 0. So that 0 is given to our D2, right? So because the D2 value is 0. So now coming to D3 and D4, here the value is A bar and A bar. So D3 and D4 we have given A and we have taken the complement of A that is given to our D3 and D4. Okay. So for D5 and D6 the value is 0 here, right? So that means we have given the value 0 to D3 and D6, D5 and D6. Now coming to D7, the value here is 8, right? So we have directly connect this A to D7. So this is a diagram for logic diagram or block diagram for your 8:1 marks, right? So thanks for watching this video. Thank you so much.